Hi everybody, I'm Kathy Resnicek.
I'm Richard Pressler.
And we're going to be looking at the first assignment in Module 2. And the first assignment looks at Layer 2 Ethernet protocols. So why do we need a whole assignment just on Layer 2 Ethernet protocols?
Because that protocol won, essentially. It became the de facto standard for nearly every type of communication that exists on the planet, really. At one time, there was different Layer 2 protocols that were competing with each other. And oftentimes,
Betamax versus VCR?
VHS.
Okay, Blu-ray.
Kinda.
Let's go
Right,
Blu-ray
right.
DVD.
We have to modernize our
I know.
analogies, right?
I know. Pong versus Space Invaders.
No, yeah, there are we've always seen fundamental incompatibilities in other industries, of course. But within the computer networking industry, you know, manufacturers, they had engineers on staff who would develop protocols. And then within that manufacturer, the equipment could communicate with each other, and it could communicate with network cards that were manufactured by that same company, but they couldn't really communicate with anyone else.
Okay.
And that's the way the industry existed for some time. For example, HP developed a standard called 100VG AnyLAN. And it was really a good standard. It was a 100 megabit per second standard. It used tokens, kind of like Token Ring. But basically, over time, it lost because it was proprietary to HP only. You would have to buy their equipment, their network cards. And Ethernet is the standard. It's the de facto standard. So when you buy a computer and it's got a little RJ45 cord on it, or port on it, that is essentially connected to an Ethernet chip. And when you buy a switch today, it's an Ethernet switch. There are not any non-Ethernet switches that you could acquire.
And Ethernet is open. It's not a particular company or product.
Yeah, essentially it's under a standards body, the IEEE. That body has decided that Ethernet, which is also called 802.3, but that is a standard that anyone can use.
Okay.
So chip manufacturers have developed chips around that standard, and then switch manufacturers have used those chips in order to build switches. And essentially, they've created an environment where, as a school district, you can buy a switch from any manufacturer, and you're almost guaranteed that it can just plug into a switch from another manufacturer and function. That's the beauty of having a standard. That's the beauty of having a protocol.
Probably really helpful. Yeah.
Oh, yeah. And within the Ethernet protocol, it addresses all the things that you need at Layer 2. So essentially, it has the necessary ingredients for physical addressing. So there's a way to say that a chip has a specific, unique address.
Okay.
And therefore, when it communicates to another chip on the network, another computer on the network, they both have unique addresses so that there's not any possible overlap.
Right.
And then a switch is able to take those addresses and understand what port of the switch that they live on. So now it's able to forward traffic efficiently. It's not sending it out all ports, but rather it's sending it just from the source to the destination.
Right.
And that's all dictated within the Ethernet standard, within that protocol.
Well, I can see why it's really important and that we want to have a whole assignment dedicated to that. So.
Yeah, definitely. And it's also a good foundation, because we're going to talk a lot about frames. We're going to talk a lot about protocol data units. So whenever we discuss a protocol, it usually has some way of creating a header and maybe a footer that encapsulates the data so that when it's sent out, the switch knows where it's going and maybe where it came from.
Oh, that's
So Ethernet is a good place to start for that, because it's a pretty easy to understand header concept, and it's pretty easy to understand how the frame is built in its entirety. And so we'll dive into that, and that kind of gives a nice framework when we go to talk about non-Ethernet Layer 2 protocols. We can always do it in the context of what we've already discussed for Ethernet.
And that's what we're going to be visiting in our next assignment.
Very good.